Okay, in section 8.3, we're talking about inverse trig functions. So first of all, an inverse function basically switches the domain and range. So now the domain of an inverse function is actually the range of the original function and vice versa. The range of the inverse function is actually the domain of the original function. So they really just switch. Now, in order to have an inverse function, you need your function to be 1 to 1. Now, sine, cosine, and tangent are not 1 to 1, which means, and it says it right here. Whoops, right here. A 1-to-1 function is a function for which every element of the range of the function corresponds to exactly one element of the domain. So for every y value, you have exactly one x value for that y value. Now, in order to test, this is going back to college algebra stuff, to test if you got a 1-to-1 function, use the horizontal line test. So if we had something like this right here, okay, well, number one, we could use the vertical line test to make sure it's a function, which means if your vertical line only crosses once on your graph, then it is a function, so that's a function. Now I need to test, is it a 1-to-1 function? Let me redraw that. Well, if I draw a horizontal line, it crosses 1, 2, so it fills the horizontal line. And you could say that that is a cosine or a sine function right there. It has that shape. So it's not a 1-to-1 function because it fails a horizontal line test. So what we have to do in order to fix that, in order to find the inverse of sine, cosine, and tangent, is we have to restrict the domain of each function to yield a new function that is actually 1-to-1. So if we look at this right here, now notice these are off just a hair. Oop. To kind of to get what is an inverse, switching the domain and range, notice the original trig functions here. Sine, your domain is all real numbers, negative infinity to infinity, where the range is negative 1 to 1. Whereas you get to the inverse of sine, well, notice your range, let me use a different color, your range is now your domain. Notice I had negative 1 to 1 here, now it's here. And now your domain is now your range. Notice I had negative infinity to infinity, well, now it's here. They just flip-flop, basically. Okay? Now, just looking at this right here, these are not 1-to-1 functions. We said that we had to restrict the domain of each function. Okay? So if I'm restricting the domain, and they're talking about restricting the domain here, which in the inverse function is actually the range right here. I hope you're still with me. Okay, so what we're going to do is we're going to take the range and we're going to restrict it. And it's not going to be all real numbers anymore. It's going to go from negative pi over 2 to pi over 2 for sine. That's important. Which, you know, that's the same thing as negative 90 degrees to 90 degrees. And I have parentheses, so I'm including the 90 and the negative 90. For cosine, it's 0 to pi, or 0 to 180. And again, I'm including the 0 and the 180. Now for tangent, it looks just like sine, except for we're not including the 90 and the negative 90 because now I have parentheses. Okay, so these are the domains that are going to be restricted to sine, cosine, and tangent. So basically, the inverse of sine, which is also written as sine, and it looks like it's raised to a negative 1, but this and this is not the same thing. In college algebra, absolutely. In trig, nope, it's not the same thing. So inverse of sine is basically defined in quadrants 1 and 4 only, because it goes from 90 to negative 90. So quadrant 1 and quadrant 4. Okay? Get rid of those. The inverse of cosine, we said, goes from 0 to 180. So here, so quadrant 1 and quadrant 2. Quadrant 1 and 2. Now the inverse of tangent, it looks a lot like sine. It is defined in quadrant 1 and quadrant, let's see, is in quadrant 4, which I don't have on there, but not at the points negative 90 and 90, or negative pi over 2 and positive pi over 2, because you have asymptotes, or the function is not defined at those points. Okay, now if we look at finding the exact values, and if they say exact values, then it means that it wants basically a fraction. It doesn't want decimals. So we're going to look at the inverse sine of 1 over 2. So the very first thing is I'm going to set this equal to theta, and then I'm going to move sine to the other side. So it looks like something that we are used to working with. Okay, so what I'm looking for here are the angles. So if I've got a 1 and a 2, well, number one, the 1/2 is positive, so sine could be in, this is going back to all students take calculus, could be defined in 1 or 2, because sine is both positive in quadrant 1 and quadrant 2. But since I'm looking for the inverse of sine goes from negative 90, oh sorry, that's positive, from negative 90 to 90, so either quadrant 1 or quadrant 4. So because of that, we have got to choose this triangle here and get rid of that one. Okay, now we know that sine is y over r, so this is 1, this is 2, this has got to be the square root of 3, this is going back to our special angles. So this has got to be 30, that's 90, and this is 60. So the angle that we are looking for is this one right here. So we can say that sine of 30, or sine of pi over 6 is equal to a half. We're writing it back into this, 30 degrees is equal to the inverse sine of 1/2. Or you could say pi over 6 is equal to the inverse sine of 1/2. Okay, so the inverse of sine of negative square root of 2 over 2. Now what we're going to do is we're going to set this equal to theta, because that's what we're looking for. We're looking for angles here. And then I'm going to unrationalize the negative square root of 2 over 2, which will give us 2 over, or sorry, yeah, I'm sorry. That'll give us 2 over 2 square root of 2. Cancel out the 2's, carry that negative with me. Gives me negative 1 over the square root of 2. Now I'll show you why I do that here in just a second. Alright, we'll go through it again. So we've got, move sine over. Sine of theta is equal to negative 1 over the square root of 2. Number one, sine is negative. So all students take calculus. It's either here or here. Since we are talking about the inverse, and inverse goes between 90 and negative 90. So either quadrant 1 or quadrant 4, I've got to take this triangle and get rid of the other one. Okay, so sine is equal to y over r. So y is the negative square root of 2. This is 1. This has got to be square root of 2. Hey, we're back in our 45, 45, 90 degree triangle. So this has got to be a 45, which that's the angle that we're looking for. Now you might say, well, okay, we can either say 360 minus 45 gives us 315, or you can say that this angle here is negative 45. Well, which one do we take? Well, this has got to go between negative 90 to 90 because that's the restriction on inverse of sine. Is 315 within this interval? Well, no. Is 45 within this interval? Yes. Okay, so sine of negative 45 degrees is equal to negative 1 over the square root of 2. Or we could say sine of negative pi over 4 is equal to negative 1 over square root of 2. So basically what we're saying, the answer to this right here is negative 45 is equal to the inverse sine of negative square root of 2 over 2. Or you could say negative pi over 4 is equal to the inverse of sine of negative 2 over 2. So either negative 45 or negative pi over 4 would be your answer for this question right here. Okay, and if we look at the inverse of cosine of negative 1. Okay, number 1, I'm going to set it equal to theta, and then I'm going to move cosine over. Now, where is cosine equal to negative 1? Now remember, if we had 1, negative 1, or 0, we went back to the unit circle. Okay, and remember, any point on here, we didn't call it xy, we called it cosine x, comma, sine x. Okay, so I'm looking for the first number within the ordered pair. So here's 1, here's 0, there's negative 1 right there, and there's a 0. So I need this one right here. So the angle that makes cosine negative 1 is pi, or 180. Okay, so we can say cosine of 180 or cosine of pi is negative 1. So the inverse of cosine of negative 1 is equal to 180 if they're asking for degrees, or pi if they're asking for radians. Okay, now let's look at this. Solve the triangle for theta, and here's our theta, here's our triangle. Okay, so what I have based on this angle right here, straight across, that's the opposite side. There's my little box represents 90, so this means this is the hypotenuse, and this is the adjacent side. So what they give me is a hypotenuse, and they give me the adjacent side. So the trig function that has adjacent and hypotenuse would be cosine. So cosine of theta, which is adjacent over hypotenuse. And in this case, adjacent is 9, and hypotenuse is 12. And I'm going to reduce that. I will take a 3 out of both of them. So you don't have to. I'm going to go ahead and do that. It'd be 3/4. But I'm not looking for cosine of theta. I just want the angle theta. So I'm going to move cosine over. So this will be the inverse cosine of 3 over 4. And then this is where you need to grab your calculator. If you are in radians, what you will roughly get is 0.7227. This is in radians right here. But if you're in degrees, you will get roughly 41